So now we're going to show you how to do this on the SPSS program. First thing we're going to do is we're going to click the variable view. We need to make some variables. I'm just going to name them factor A, factor B, right? A is going to be the serum amount. B is going to be the smoothie size. And then we have a DV, that's the number of push-ups. What else do we need up there? That's about it. But okay, so now let's go into the factor A. I'm just going to go ahead and label this the strength serum. And under values, it has 3 different values, right? 0 is going to be the control group, or 0 milligrams. Add. Oops, let's clean it up a little bit. That looks better. Okay, the number 1 is going to represent the group that got 10 milligrams. And 2 is going to be the group that got 20 milligrams. So those are our 3 different levels of our factor A. Okay. Factor A is a categorical variable, right? Puts everything in one of these 3 categories. Click OK. And our measurement is going to be what we call a nominal, same as categorical. Okay, so factor B. I'm going to switch the decimals around. We don't need any decimals. We're just going to deal with whole numbers here. Back to factor B. Bam, 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 bam. That was the size of the smoothie. We're going to go into our values, and we'll just make the number 1 be the small. And number 2 is going to be the large. Click add. Okay. And again, this is going to be a nominal variable as well. The DV is simply going to be what we call a scale data or a score data. And let's go ahead and start entering data. We're going to click down on the data view button. So our factor A was broken down into 3 separate levels, right? 0 milligrams, 10 milligrams, 20 milligrams. So that means there are going to be 12 marked with a 0. Right, those represent the 0 milligram group, and then there's going to be 12 marked with the 1. They're the 12 that got the 10 milligram group. So we should be at 24, and the last group is going to be the ones that got 20 milligrams, and we're marking them with a 2. So remember, these are all categorical variables except for the DV. That means that every number represents a different category. Okay, so that takes care of the factor A. Factor B, as you recall, it might help to look at the actual columns of the data. So the first A, right, it's really A1, is the same as a 0. That means they got no drug. So if you look at the data, we have A1, B1, and A1, B2. So A1, B1, that means that the first 6 got a small smoothie. The second 6 got the large smoothie. And that pattern is going to repeat all the way down for all the different levels of A. So let me just cut and paste that in. Let's try that again. Stupid computer. Copy. Paste. That worked. Copy. Paste. So we're good to go. I'm just picking one at random. So number 29. So if he has an A of 2, that means he's in the 20 milligram group. And if he had a 1, that means he got a small smoothie. And then now we have to type in the DVs. Okay, going by the table of data, make sure you type it in carefully. The first one is 15. The next one's 16, 14, 17, 13. Oops, I told you. Be careful. And 15. And hold on a second. I'm just going to go ahead and type in all the data. You don't have to watch this. Here's all the data. So I always just eyeball it to make sure there's no crazy missteps, which happens normally. Okay, we're good to go. So, hard part's done. We're going to go to Analyze. General Linear Model. Univariate, because we only have one dV. Whatever you want. So that's the number of rat push-ups. Okay, so that's going to be our dV. And there's factor A, factor B. They get into fixed factors. I'm going to click a couple of these buttons. What a day I'm having. A, B, add, continue. Post-Hoc Tests. Normally I only pick one. And to have a post-hoc test, you need a minimum of 3 groups, so there's no use to do an A. No use to check a post-hoc test for B, because it only had 2 groups, but A had 3. And I always pick the Tukey test, because it will do all pairwise comparisons for you. That's pretty handy. And options. Overall, I always just do them all. We always need the descriptive statistics. That's the mean, the standard deviation, that kind of stuff. For an ANOVA, you need effect size, right? That tells you, how strong your ANOVA is. Power, same thing. It kind of supports your F score, and we have to make sure that the homogeneity of variance is there, right? The 3 assumptions of an ANOVA are the data is relatively normal, the variance is relatively the same. That's what the homogeneity of variance is all about. And the last one is independence of observation, and that's not mathy. That's just something that you have to check for. Okay, so that looks good. We click OK, cross our fingers, and here's the output of the data. Right? Between subjects, it tells you which are the factors. There's factor A, factor B, and how many different levels, how many are in each group. Here's your descriptive statistics. There's all your means and everything. And here's our Levine's test of homogeneity of variance. If this significance was less than 0.05, that means we would have violated the assumption of homogeneity of variance, and you would have to do something with your data. If not, you could not use the ANOVA, right? This has to be good before you can proceed with the ANOVA. Okay, so here's our big ANOVA table. Okay, between subjects. Forget about the model and the intercept. Factor A, so that's the drug. We look at it, and these scores are practically the same that we did by hand. A big F, a significance of less than 0.05, and here's our partial eta squared, right, which is our effect size, right? Bam. And those are all good. Boom. B, again, a small f. It is not significant. We kind of knew that. Partial eta squared, very small. Okay. Here's our interaction term. And again, it gave us a huge f, and our significance was less than 0.05. So this agrees with our by hand. And that's just about it. Post-hoc tests, right? It'll show you exactly where the significant difference is. So this tells us, you just look down a significance column, that's the same as a p-value. So anything less than 0.05, there would be a significant difference. So what this is saying is that at between the 0 milligrams and the 10 milligrams, there's a significant difference. Kabam. Between 10 and 0, right, it just repeated itself. And between 20 and 10, there was a significant difference. So there's a significant difference between the 0 and 10 and 10 and 20. And that's all we need to know. And I hope this helps. MGZ out.